Hi everyone, today we're going to talk about how to determine gradient on a map and what that is. So let's start with what gradient is. Gradient is how fast or slow the value on a map changes within a certain distance. For example, it might show the how fast or slow air pressure is changing or elevation is changing on a map within a certain distance. For instance, on an isobar map or a pressure map, or even an elevation or contour map. Notice that in my isobar or pressure map and in my contour lines map, right here on my elevation map, this area is where I have high gradient, meaning there's a fast change in value on these map within a certain distance. So in my pressure map, notice that my pressure is going from 1000 to 1004 to 1008 within this distance really fast. And same thing over here, my elevation is changing very fast in this area on my map within a certain distance. That's what I mean by high gradient. Um, in contrast, this area on my pressure map is low gradient, meaning there's a slow change in the value on the map within a certain distance. Notice that my pressure is going from 1020 to 1016 to 1012 very slowly within this distance. Compared to here, where we had higher gradient, my pressure was changing much faster within that certain distance. Same thing with my elevation or contour lines. I have low gradient here because my elevation is changing pretty slow over here compared to this area where I had high gradient. My elevation was changing much faster. So, how do we show that on a map? What patterns are we noticing? Notice that in areas where my value is changing fast, or in areas where I have high gradient in a certain distance, my isolines are much closer together. My values change faster in a certain distance when my isolines are closer. And in this area, I have a low gradient, and notice my isolines are farther apart where I have low gradient, meaning my value is changing much slower in that area within a certain distance. So high gradient means closer isolines and low gradient means farther isolines. Let's write that down in your note packet. When my line spacing for isolines are closer like this, I have high gradient. The values are changing faster within a certain distance. Where my isolines are farther apart, I have low gradient, meaning my values are changing slower within a certain distance. Pause this video and write this down. So let's talk more about elevation gradient. Elevation gradient is how fast or slow the elevation on a map changes within a certain distance. Let's talk about slope first. In areas where I have gentle slope, my elevation of the land changes slowly, kind of like over here. My elevation is slow, it's changing slow, so this is an area that would be easy for someone to climb versus that an area with a steep slope. A steep slope is where elevation of the land changes quickly, kind of like here. This area is considered a steep slope because my elevation is changing so quick that this would actually be harder for someone to climb up. Okay, now that we know what's gentle versus steep slope is, notice the contour lines for an area of a mountain where we have steep slope versus a gentle slope. Notice that where my elevation is changing faster in areas where I have a steep slope, my contour lines are also closer together. This is showing my elevation is changing much faster within a certain distance. In areas where I have a gentle slope or where my contour lines are changing, my elevation is changing slower, my contour lines are farther apart because my elevation is changing, my values for elevation is changing much slower within a certain distance. So contour lines closer together means steep slope. Contour lines farther apart means gentle slope. Let's write that down. Well, pause this video and write your notes down. When contour lines are closer together, I have a steep slope. My elevation is changing faster. When my contour lines are farther apart, I have a gentle slope. My elevation is changing slower. So, what happens if a stream went down a steep slope versus a gentle slope? Well, if I had a steep slope and I had a river or stream flowing down it, it would kind of be like a waterfall. It would flow very fast because of gravity, right? So, in steep slope areas, kind of like here, a stream would flow much faster because of gravity compared to an area with a gentler slope. A gentle slope area would have a slower stream. And remember, once again, steeper slopes are represented by closer isolines, gentler slopes are represented by farther isolines. So if we put that all together, slower streams are found in gentler slopes and they are represented by farther lines, right? So if you saw farther lines and I asked you, where would a river flow faster? A steeper in an area with closer lines or an area with farther isolines? The answer would be steeper slope or closer isolines because the river would flow faster in a steeper slope or area where the lines are closer together in an isoline map. So in the same way, faster streams would be found in a steeper slope area, and steeper slope areas are represented with closer isolines. So in an area with closer isolines, a river would flow faster. In an area with farther isolines, a river would flow slower. What about pressure? Well, pressure gradient is how fast or slow the air pressure on a map changes within a certain distance. So this is an isobar map or an air pressure map. Notice that in this area, my pressure changes very slowly within this distance. My values for pressure are changing slowly, right? But in this area, my pressure is changing quickly. My values or lines for representing pressure is changing very quickly in this area of my map. The thing about wind is that wind speed depends on air pressure. We already said that wind moves from high pressure to low pressure in our previous unit, but winds also move faster. Or the faster the air pressure changes within a certain distance, the faster the wind speed is. So, the faster the air pressure changes, the faster my wind flows. So, over here, my air pressure is changing pretty slowly. Remember this map? My air pressure within a certain distance is changing pretty slowly. That means if a wind were going to blow through this area of the map, the winds would move slower because the air pressure is changing so slow. And in this area of my map, my pressure is changing quickly. That means winds would also flow faster there because my air pressure is changing faster. The faster the air pressure changes, the faster my wind speed is. Let's write that down in our notes. Pause this video. The closer my isolines are, the faster winds or faster streams there are, and the farther my isolines are, the slower winds or streams I have. Same with slope, right? The closer the lines are, the steeper the slope, the higher the gradient. The farther the lines are, the lower the gradient and the gentler the slope because things are changing slower when the lines are farther, and their values are changing faster when the lines are closer. One more thing to remember is contour interval. So normally in the bottom of a map, you'll see something called contour interval, and it will give you a number, right? Contour interval is the difference in elevation between each line on a map, and there must be equal spacing. So what does that mean? Say I have a map, right? And I'm given the contour interval is 20 feet in the bottom of the map. That just means that every single line is changing by 20 feet of elevation. Okay. So if this is 500 and this is 600, I know as I'm going from 500 to 600, my value is going up. For each line to know how much my value is going up by, I look at a contour interval. And since my contour interval is 20 feet, I know that my value is increasing by 20 feet with each line as I go towards 600. So if this is 500, this would be 520, and this would be 540, 560, 580, 600. So contour intervals give you an idea of how much each line is going up, or the value of each line is going up or down by. So let's start with question number 4. Base your answer to this question on the map below. Notice that for question number 4, I have contour interval of 200 feet, meaning each of my lines are changing, values are changing by 200 feet as I move from one line to the next. So if this is 3,000 and this is 4,000, and each line, my value is changing by 200 feet, then I know from 3,000 to 4,000, my values are going up and it was going up by 200 feet per line. So if this is 3,000, this is 3,200, this is 3,400, this is 3,600, and this is 3,800, and finally 4,000. So let's look at 4A. It says describe one piece of evidence shown on the map that indicates that the northeastern side of Slide Mountain, the area that I highlighted, has the steepest slope. Or in other words, how do I know that this area has the steepest slope compared to other areas? So notice that this must be Slide Mountain because it's represented by like a circular thing. So this must be the whole area is Slide Mountain. This must be the top of Slide Mountain. So this is the northeastern side of the mountain. If I'm looking at the contour lines, I see that the contour lines are much closer on this side compared to any other side of the mountain. And remember, when contour lines are closer together, I have steeper slope and higher gradient. When the contour lines are farther apart, I have lower gradient and gentler slope. So the part of the map that has the steepest slope would be the closer isolines. So that could be your answer. Here are some answer options. You could say in this area the contour lines are closer together, or the spaces between the contour lines are smallest in this area. There is a greater change in elevation over a shorter distance on the northeastern side. You could say there are more lines on the northeastern side of the mountain, or you can say that the isolines are closely spaced on this area. Choose any to write down your answer for this question. So for B, it's saying determine one possible elevation of point X. So to find the elevation, let's look for the contour interval again. Remember, we already marked down what each of my lines represent one elevations, right? So if X is between 3,600 and 3,800, you can get one credit if your answer is a value that is greater than 3,600 feet and less than 3,800 feet. So any of these answers between 3,600 and 3,800 would work for your elevation here. So go ahead and try question number 5. Pause this video. Once you're done with it, go ahead and unpause to check your answer. Question number 5 is asking, base your answer to the question on this map below. A. Describe how the contour lines indicate that Coal Creek flows faster between location D and E than between locations F and G. So it's asking for how the contour lines are showing that. So we have to talk about the contour lines. And notice between D and E, my contour lines are closer together. And between F and G, my contour lines are farther apart. So these are your options, for your answer. You can say contour lines between D and E are closer together. You can say contour lines between F and G are farther apart, indicating a slower stream velocity. Since it's asking how the contour lines are showing which way the streams are moving faster or slower, remember, I have to go back. Faster streams or winds are represented by closer isolines, and slower winds or streams are represented by farther isolines. You can also say contour lines are closer together, indicating a steeper slope or gradient. You can say there is a greater elevation change between D and E, so you know that the stream flows faster there. Just note that you cannot get credit for saying D and E are closer because F and G are the same distance apart, meaning that D and E and F and G are basically the same distance apart from each other. That doesn't really tell us, even though D and E and F and G are same distance apart from each other, notice that there's still more contour lines between D and E and there's less contour lines between F and G. So it's not about the how far away D and E or F and G are from each other, it's about how many contour lines are in between or how close the contour lines are. So don't say that. Another thing you cannot get credit for is if you say the slope or gradient is steeper alone. So if you only say that, you cannot get credit. You have to say how that impacts stream velocity, right? Or because if you just said that alone, it does not indicate how contour lines show a steeper slope. You also have to talk about the contour lines. So these are your options. Choose one. For B, it says describe the evidence shown on the map that indicates a Coal Creek flows towards the northeast. Here are your options. You could say contour lines bend upstream when they cross Coal Creek. Contour line elevations decrease towards the northeast along Coal Creek. The V shapes of the contour lines point upstream towards high elevations. Lower elevations are towards the northeast. Contour lines make V shapes that point southwest. Contour lines are bending in the opposite direction. Just don't say water flows downhill because that doesn't give us more specifics on how the contour lines show it. If I'm looking closer, I see these V shapes right here. These are actually much easier answer options. These are your region's answer options. But what I would like you to say is the pointy part of the V shows where the direction the stream is coming from, and the opening of the V shows where the direction of the stream is going towards. You can also say contour lines bend in the direction the stream is coming from. Okay. Um. Next, before I move on to the next question, which is C, Remember, hills are represented by these circles on a map, but depressions are represented by circles as well, but they have these hatcher marks indicating that my elevation is getting lower, right? So if I look at this area on my map, I see hatcher marks, meaning this area is a depression. My land or elevation is getting lower here. So if this is 340 and I'm asked what the elevation of A is, then and I'm given that the contour interval is 20 feet, I can just figure out that, oops, sorry. If this is 340, this must go down by 20 feet because the hatcher marks are showing that my elevation is going down. So this line must be 320. Sorry, I should have given an arrow. And that means that this line must be going down by another 20 feet. So this line, A, where A is 300. So the answer for elevation is 300 feet for location A. So go ahead and pause this video, try question number 6. And yeah. The contour map below shows a lake and river system. The Birch and Elk rivers carry an equal volume of water. Compared to the Elk River, the Birch River can best be described as flowing A. Faster in the same general compass direction, B. Faster in the opposite general compass direction, C. Slower and in the same general compass direction, or D. Slower and in the opposite general compass direction. So the correct answer is actually A. Compared to the Elk River, the Birch River is flowing faster. I know it's faster because the contour lines are closer together in the Birch River compared to Elk River. And to know which direction they're going, notice that they're both going towards the northwest area. Remember, the pointy part of the V is where it's coming from. The opening part of the V shape that the contour lines are making is where the direction where the stream is going, right? So they're both going in the same direction. That's why it's A. Birch River is flowing faster than Elk River, but they're going in the same general compass direction. So for the next one, number 7, go ahead and pause this video, try number 7. And unpause when you want to check your answer. 4 locations A, B, C, and D are represented on the topographic map below. Which letter location has the highest elevation? The correct answer is actually B. And here's why. To know which way a river is going or where the highest elevation is, and I'm given a river, remember, streams always flow from high to low elevation. So, which way is my river flowing? To figure that out, I'm looking at the V shapes that the contour lines are making, kind of like this. And now that I know these are my V shapes, the opening part of the V is where the stream is going. The pointy part of the V is where the stream is coming from. It looks like the stream is going this way towards the eastern side. And if the southeastern side, and remember, streams always from high to low elevation, B must be the highest elevation. That's where the stream would be coming from. And this must be the lowest elevation where the stream is going. So the correct answer is B. So in the next video, we'll talk about gradient calculations. Thank you.